Okay, so we'll solve this numerical of block A weighing 1 kilonewton. So this is block A weighing 1 kilonewton. Rest on a rough inclined plane whose inclination to the horizontal is 45 degree. This inclination is given here 45 degree. Okay, thus this block is connected to another block B. So this block A is connected to block B using this rod. Okay, this is weightless rod. Okay, this block is connected to another block B weighing 3 kilonewton, rest on a horizontal plane. So this block B is resting on a horizontal plane by a weightless rigid bar. This is a rigid bar which is inclined at 30 degree to the horizontal as shown. Okay, then so we have to find the horizontal force P. We have to determine this horizontal force P required to start the motion of this block. Okay, just to move the block A in the upward direction. So this block A is going to move in the upward direction. So obviously this block B will move towards left direction. Okay, this is direction of motion. Okay, for block B, and for block A direction of motion will be upward. Okay. Now, so methodology of solving this numerical. So if we consider ability of block B first, so it will be contain 1 here, 1 here, and P. So 3 unknown will be there. Okay, P, this reaction at this point, let's name it as point 2, and this rod. So when its rod is there, so by simple common sense you can say that when you apply this force P here, so this block B will move towards left, this block will move upward. So this rod will contain a compression nature. Okay, this force in this rod will be of compression nature. Okay, so here number of unknowns are 1 2 3, and here numbers of unknowns are 1 and 2. So here only 2 unknowns are there, so we have to first solve the APD of this block A. Okay, so drawing the free body diagram of that block A. Okay, so that this will be the APD of block A. So active forces 1 kilonewton force, this compression force in that rod, let's denote it by C. Then here at this point of contact, let's name it as surface 1, point of contact 1, so that it will be contain this perpendicular reaction. Okay, N1, this here it is perpendicular, denoted by N1, so that is angle of 45 degree with the horizontal, and the frictional force, so that will be parallel to the surface. Whatever this surface of contact is there, friction force will be tangential to that surface or parallel to that surface. Again, its angle with horizontal will be 45 degree. Okay, that simple thing is there. When you draw perpendicular here, this angle is 90 degree, this 45 degree is given, so obviously this angle will be 90 minus this 45, so this will be again 45 degree. So angle of reaction N1 with horizontal will be 45 degree. Okay, then for F1 we can write F is equal to fundamental definition, limiting frictional force is equal to mu into N. Okay, F is equal to mu into N, so we can write F is equal to 0.268 into N1. Okay, so again by using conditions of equilibrium. Okay, so by using conditions of equilibrium we can solve this up to the C. We can determine the value of compression force in that member C. So using condition of equilibrium, so summation Fx 0, so that will be, now forces will be resolved like this. So I am showing resolution here. So it will be C cos 30 degree, and here C sin 30 degree. This force C is going towards second quadrant, so y component will be positive whereas x component will be negative. Then this N1 going toward first quadrant, so this, that will be N1 cos 45 degree and N1 sin 45 degree. Okay, then this F, so it is going toward fourth quadrant, so it will be resolved like this: F1 cos 45 degrees, and vertical component I am writing it here, so that will be F1 sin of 45 degrees. Okay, so resolving these forces and writing the equation. So summation Fx is equal to 0, that means algebraic sum of horizontal component of forces, whatever forces which are horizontal in nature, so its sum is equal to 0. So that will be F1 cos 45, so this force F1 cos 45, it is acting towards right, therefore I have written that positive, plus N1 cos 45, so again this N1 cos 45 minus, now this C is x component going to our left direction, so that will be negative, so minus C cos 30 is equal to 0. So again solving this for C cos 30, see, we are, the methodology will be like this. Drawing the FBD of A, determining value in the compression force in that rod, then using that compression force here, determine the value of force P. So we are interested in value of C, so I am writing in terms of C. So C cos 30 is equal to, so this minus C, it is going to the left, so that will be right side, so that will be positive, and whatever value here, that will remain here. Again for F1 we can write 0.268 N1, that will be mu into N1. So writing C cos 30 is equal to 0.268 N1 cos 45 plus N1 cos 45. Again solving this on the calculator, we will get C cos 30 is equal to 0.8965 N1. Okay, then using the second condition, summation Fy is equal to 0, that means the algebraic sum of vertical component of forces is equal to 0, so that will gives us here downward, therefore writing it as negative. So minus 1 plus N1 sin 45 minus F1 sin 45. Okay, so this F1 sin 45, N1 sin 45 acting upward, therefore it is positive. F1 acting downward, therefore it is F1 sin 45 will be negative, plus again C sin component, so it is acting upward, so positive. So plus C sin 30 is equal to 0. Again solving it for C sin 30, so that will be 1. So now here C is positive, so whatever other terms are there, that will go toward the right hand side. So minus 1 will become plus 1, plus N1 sin 45 will be minus N1 sin 45, and minus F1 sin 45 will be plus F1 sin 45. So again here we have to write it as positive. Okay, so that C sin 30 here plus F1 sin 45. So again when you solve this, so you will get done. Okay, so solving that, you will get C sin 30 is equal to 1 minus 0.5176 N1. Okay, so again solving this equation 1 and 2. Okay, so we will get value of N1 as 0.966 N, and putting that value in either equation 1 or 2, we will get value of C as 1 Newton. Okay, so we have got the value of C. So drawing the FBD of B, we have to determine the force P. So FBD of B will be like this. So the free body diagram of block B will be like this. So it is resting on horizontal plane, this block P is resting on horizontal plane. So again removing all the supports and showing the reaction. So compressive force in that rod C, its weight acting vertical downward, normal direction, and frictional force. Now this block direction of motion will be towards right, so frictional force will be towards left. Okay, again one point is remain there. In the question it is given that angle of friction is 0.15, so value of mu, that will be equal to tan of phi, so that will be equal to tan of 15 degree. Okay, that's how I get this 0.268. okay, so mu will be equal to 0.268. okay, so again that F1 is equal to 0.268 into normal direction frictional force. Now frictional force will be towards right because the direction of probable direction of motion will be towards left. So again using condition of equilibrium, so summation Fx will be equal to 0. So using this condition, so minus P plus C cos 30, again C we have to resolve it, so that will be C cos of 30 degree, and vertical component C sin of 30 degree. Okay, and so plus F2 is equal to 0. Again for F2 you can write 0.268 and 2. Again for P, so that will be value of C, so 1 cos 30 plus 0.268 and 2. Now we can name it as equation number 1. And using the second condition, summation Fy is equal to 0, so that will be upward N2 minus 3 minus C sin 30 is equal to 0. So putting value of C here, so you get value of N2 is equal to 3 plus 1 sin 30, so that will be 3.5 kilonewton. So putting that value in equation, putting N2 in equation number 1, we get value of P as 1.8040 kilonewton, and that will be the final answer. Okay.